India's border with Eurasia could cause it to split horizontally in two. The Himalayas are expanding because of the migration of the Indian plate, which encompasses much of contemporary South Asia. Approximately 60 million years ago, the plate initially collided with Eurasia, initiating this process. Dutch scientists have visualized what this area would look like in the future by utilizing the capabilities of an AI simulator. According to the computer model, the Horn of Africa and the Indian subcontinent will combine in about 200 million years. Situated along the recently constructed mountain chain, which geologists have tentatively named the Samoa, the modern cities of Mumbai and Mogadishu will become next-door neighbors. On the other side of this geological structure, Madagascar will join Sumatra and Kolkata, and the island of Mauritius will occupy the space in between. Once it was incorporated into the Indian mainland, Sri Lanka would vanish from existence. As the Indian plate continues to shift north, geologists believe that the Himalayas will continue to rise in height in the near future. The surrounding terrain will undergo significant changes, and the current fault line will move farther south. In tens of thousands of years, Nepal might not exist at all. The Himalayan range will have moved sideways to completely enclose the mountainous nation, and as a result, there might be far more earthquakes in this region of the planet. The majority of scientists concur that India is only progressing a tenth of an inch towards Eurasia annually. Some of them believe that Tibet's lofty topography results from the buoyancy of the plate, which keeps the Indian plate from sinking into the mantle. According to some academics, the structure is buckling under pressure, which is similar to what occurs to a sheet of paper pressed horizontally against a wall. The sheet rises in the middle as more pressure is applied to its edge. This bulge is the Tibetan Plateau in the actual world. We have the third explanation for the process according to a recent theory. Although peer review is still required for their manuscript, the results are fascinating. The delamination of the Indian plate was a novel idea presented by the multinational research team. In a substance that is meant to be linked together, this word simply refers to the separation of layers. Imagine a sandwich made of two buns with slices of gammon and cheese between them. If you remove one of these layers, you will experience delamination. Geologically speaking, this process entails the upper plate ripping off and rising. This portion of the Indian plate is responsible for Tibet's height. The denser, lower portion of the plate causes it to sink into the mantle. This is how plate tectonics is like a layered cake. Cooks put the denser, spongier layer at the bottom so the heavy top doesn't crush it. Researchers examined helium gases and water samples from the area's hot springs to build their thesis. A rare isotope called helium-3 indicates that the Earth's mantle is located near the surface. Scientists observed helium isotope ratios in 200 springs in Tibet. The resulting pattern indicates the proximity of the mantle to the northern Tibetan surface. The discovery of abundant helium-4, an additional isotope, further to the south, indicates that the plate is still intact and creates a barrier that helium-3 cannot cross. With the exception of a small area in the eastern Himalayan region close to Bhutan. The region's seismic activity demonstrates that the mantle is penetrating from the eastern side of the plateau and provides strong evidence for the validity of delamination, or the sandwich theory. The conventional wisdom on the behavior of tectonic plates is called into doubt by this idea. The Indian plate is thinnest on its sides and thickest at its northernmost tip. The scientists conducting the investigation believe that its unusual shape plays a role in the delamination process. If everything is as it seems, the nature of continental collisions is more dynamic and intricate than geologists have previously believed. Scientists just have indications as of yet, not enough concrete data to support the new theory's accuracy. Currently, there is no mechanical way to drill down more than 60 miles. Yet these kinds of excavations are required to confirm beyond a reasonable doubt that the delamination process is underway. We would be able to comprehend the risks connected to earthquakes in the Asia-Pacific area more clearly with the use of appropriate technology. 75% of the volcanoes on Earth are found in the well-known Ring of Fire, which is located there. Here is where the 9 out of 10 earthquakes occur. For the purpose of resolving Earth's tectonic puzzles, the India-Australia-Capricorn tectonic plate beneath the Indian Ocean is equally crucial. When tectonic plates are just beginning to push or pull apart, it is referred to as a nascent plate boundary by geophysicists. This is the first stage of a fully formed plate border. The rate at which this geological change occurs is a meager 5% of an inch each year, roughly the same length of a spaghetti thread. From a modern point of view, this shouldn't concern us too much because the India-Australia-Capricorn plate is set to break in half over tens of millions of years. After examining the records of 2 earthquakes that occurred in 2012, French scientists came to the conclusion that a developing barrier must exist there. While tectonic plate boundaries are often the site of earthquakes, the Indian Ocean tremors occurred in the center of the plate. The scientists used sonar scanning to map out the seafloor and determine what was actually going on there. Researchers discovered a complicated network of 62 pull-apart basins along a fracture zone after conducting additional investigation on the marine area off the coast of Western Australia. The tectonic plate was slowly but surely splitting apart, and the scientific data supported this theory. This is more evidence that the outer layer of our globe is dynamic rather than static. In certain instances, one need not be an expert in science to identify these potent subterranean forces. In a seismically active area in rural Kenya, enormous fissures appeared very instantly as a result of intense downpours. Both in 2018 and 2023, the locals dubbed the largest of these the Grand Kenya. These were not isolated episodes, but rather indications from the Great Rift Valley's East African Rift System. This massive geological feature, which stretches from Jordan to Mozambique, illustrates how the African continent gradually divided into 2 subcontinents. Rift valleys serve as evidence of how tectonic plate movements are transforming the planet and can be found all over the world. The Nubian plate bears much of Africa, while the smaller Somali plate cradles the Horn of Africa. The East African Rift illustrates the underlying dynamics of these 2 plates. Cracks are starting to appear in the Rift Valley as a result of the 2 slowly drifting apart. The division of Africa into 2 continents is the ultimate result of this continental rifting process, which is occurring at a rate of marginally quicker than that of India. This entire process, which is set to occur during the next 10 to 50 million years, represents an important geological event that serves as a reminder of the historical changes that have occurred on Earth. The Jurassic period is the last time the topography of our planet underwent such significant alteration. Although the global map from that era appears familiar, the placement of the geological masses is strange when viewed from a contemporary standpoint. Known as Laurasia at the time, Eurasia was still only tangentially linked to North America in the north, where it was gradually separating from the supercontinent Gondwana. It included what is now known as Africa, South America, Australia, and Antarctica further south. The Indian plate was at the time situated closer to Madagascar than it is to Eurasia.